Hey folks, I thought I'd share with you some additional practice things that you can do that are based on what you worked on with the gasket, just some additional um, examples of some drawings that include tangencies and figuring out some geometric construction. So I have these 9 little drawing problems that you can do for extra credit. If you attempt all of them and are able to do them with 100% accuracy, then you can get 100 points that will be counted at the end of the semester, and only if you've completed all the required assignments. If you attempt all of them and you just have some minor errors that I feel like you still got the gist of it, I can give you 75 points that can again get counted at the end of the semester. But it's still just good practice. And so what I'm going to do is do some quick videos that show you how to solve some of these problems. So the first one we're going to look at is drawing a line at a random length and angle, and then dividing that line into equal segments. And I'm going to show you the way you can do this if we were using the divide tool in AutoCAD. So in order to get this started too, we need to go ahead and open a new drawing file, and the dimensions that are being shown 1.5 is 1.5 inches. So we can go to No Template Imperial, and I'm just going to begin to draw these. There are no drawing start points or end points, so you can just kind of draw these in your model space area, assuming that they're going to be 9 little drawings for you to get to fit on your sheet. And there's a layout video that you can watch that shows you actually how to set up the layout so it looks like this on the sheet when you're done. So let's start with the line drawing. I'm just going to type L for line and draw a random line at a random length at an angle. Next, we're going to use the divide command, and I want to just select that line and divide it into 7 equal segments. So I type 7 at the command line. Now, it doesn't seem like much happened, but the reason for that is there's little tiny nodes that got placed along the line, and we just can't see them because DDP type, which is, oh, it looks like I have to do point style. Let's see if this is one of those examples where the command for the point style changed. So I need to find where it is now. Let's go under, well, let's go to help. Point style. So I can change the point style by using, no, it's not quite right. Let's see, point style dialog box. P type command. So let's try that. So I'll minimize that and type in P type. There we go. So that's the new way to get that point style command up. This will change the point style so that it will appear as these different symbols. So let's try that one and apply it. So now we can see that that line's been divided into 7 equal segments. So it's a good idea for us to maybe set up some layers. And let's create an object layer, a center layer, because we're going to have some center line types, and a construction layer. And let's also create a dim layer. So we'll create all these layers, and these will be what we use to complete the drawing and include some of the dimensions and the callouts. And we'll load a center to line type. Okay, so yeah, in the cons layer I want to be orange. I like using orange for my construction lines, and I've set it to no print. And actually we do want to have, so I'm going to use that cons layer to copy. We do want a viewports layer. And I'm just going to make it a slightly different color than that orange, but both of them should be set to no plot. So now I can go to the object layer, make that the current layer, and close. And what I want to do is take just those points right there and put them on the cons layer. So when I print this, those won't print. And then that line should be on the object layer. Perfect. All right, so when we look at our line weights, let's see what happens. We can see the line weights. Perfect. All right, so the next problem that we have is creating, I'm gonna just demonstrate these two next at the same steps. We're going to create an arc with a radius of 1, and then we're going to make these two lines tangent to that arc. So I'm going to do this by drawing the lines first. So I'm going to draw a line that is not parallel or not in a 0 or 90-degree direction. This is an acute angle, so this is going to match this problem right here. Notice that I'm not concerned about whether or not I have the angle right. I just need to know what's the size of this radius, and I'm going to make an arc that fits inside this radius. Let me just explain the geometry a little bit first, and then we will use the actual tools in AutoCAD to create this. But the geometry works like this. If I were to create a line, another line parallel to each one of these with an offset, I'm using the offset tool of 1 inch. So with offset, you can type in offset, put in a distance, and pick a line or a circle or an arc and offset those distances. The problem with the way I have this drawing laid out first is this angle is a little bit too small. So I'm just going to extend these lines a bit longer. Notice I'm not changing the angle, just extending them a bit longer. And I'll go back into an offset. The setting is still 1 inch, so I'm going to hit enter. And then pick the line and pick the direction I want that line to offset in. Now these two lines I'm going to put on the construction layer. Now if I draw another line using that intersection I created with the two offsets of the lines exactly 1 inch from the first angled lines we started with, and then I use Shift, right click, and pick perpendicular, I've now determined where this tangent point of an arc that has a radius of 1, because that's why we offset these lines 1 inch to match that radius. I've determined where that tangent point would be. So if I do that again on the other side, I want to type Shift right click and click perpendicular, and I've found those two tangent points. So if I use the arc tool, and specifically I use start end radius, I should be able to pick the two locations and then put in a radius of 1, and the arc comes in exactly where it's supposed to and tangent to those lines. So if we put that on the object layer, whoops, now I can trim the rest of these lines away, and I have the correct solution. Now here's a faster way to do the same thing. I'm going to take the original two lines and use the fillet with a radius set to 0 to get those two to connect again. And this time I'm going to use the fillet command with the radius set to 1 and see what happens when I click those two lines. I get exactly the same result. So what I'd like you to do is try that same thing, but with a obtuse line. So you're going to create two lines at an angle that is a larger than 90-degree angle, and see if you could make an arc that is tangent to those two lines. But now you understand where the geometry comes from and how we can find tangent points, and then we know the tool that we can use in AutoCAD to create that tangency. All right, I'm going to stop there because I don't want these videos to be too long, and we'll go ahead and do the next row of problems in the geocon.